Hello and welcome to this Bioprocess International Ask the Expert webcast. I'm your host, Leah Rosen, the online editor for Bioprocess International. Before we get started, just a couple of notes. This webcast is being recorded and will be made available for replay in the multimedia section of our website. We've muted the audio lines, but we welcome you to type in your questions for our speaker in the chat window on your screen. After the presentation, we will begin the question and answer portion, and I will ask our speaker your questions from the chat window. Your questions in the chat window will only be visible to myself and our speaker. So thank you for joining us today. It is now my pleasure to introduce our speaker, Phil Yuen from Repligen.
Hi, and thank you for the kind introduction. Hello everyone, and welcome to today's webinar. I can see that some of you are familiar with TFF already, so hopefully today's webinar will shed some more light on Repligen's TFF systems and solutions. And for those who are not, I hope I can give you a brief introduction into the technology. So today's discussion will be about the KrosFlo KR2i system, a turnkey benchtop system for walkaway TFF automation for process development and lab scale production. I'll also be presenting on conductivity and UV-based TFF process control using the new conduit module. Today, I will discuss the key features of the KrosFlo KR2i TFF system, key components enabling automated control, and the multiple modes of automated TFF operation. I would also like to introduce the new conduit module and its features, and I will close by talking about systems for scaling up TFF operations and single-use filtration assemblies that can be utilized with our KrosFlo systems. The KrosFlo KR2i TFF system from Repligen is a turnkey benchtop system for TFF process development and small-scale processing, and an ideal system for UFDF applications and downstream processing. The KR2i system is the most economical lab-scale TFF system on the market today and enables operations of both hollow fiber filters and flat sheet cassettes. The system allows for precise and reproducible control and data logging of TFF operations through the KFCom control software. Automated process controls are also made simple with the KR2i as it interfaces with scales and pumps in a number of preset modes. Today, we will discuss why over 1,600 systems are in use in the industry today and how the KR2i can enable automated lab and pilot scale processing and more rapid process development of TFF operations. The KR2i is optimized for development and pilot scale operations with working volumes from 1 mil to 10 liters. The peristaltic pump on the main drive can support flow rates of up to 2 liters per minute. Repligen offers multiple automated and integrated TFF systems, so operations can be scaled linearly from the KR2i system to our KMPI system. I will discuss the KMPI a little later. The KR2i is modular in nature and is highly configurable and flexible so that it can be tuned for your particular application needs, increasing process efficiency. The system features real-time pressure monitoring and automated back pressure control, driving process definition and execution from batch to batch. The KR2i is both ready and easy to use so that system proficiency can be attained quickly. Combined with ready-to-use, fully assembled flow path assemblies that contain either Spectrum KrosFlo hollow fibers or Tangenix flat sheet cassettes, setup times between batches or runs are minimized, saving time and increasing process efficiency. The KR2i enables optimal process economics because the system has a small footprint and the price point is at a fraction of the cost of alternative systems. The KR2i does not have a fixed flow path, but rather can be used with configurable flow paths, driving enhanced flexibility. The KR2i can be used with our closed custom flow paths, which reduce contamination risks. Taken together, the automation and data logging enables more efficient process development work. The KR2i system was designed for downstream processing and can be used for UFDF application work associated with the purification and formulation development as shown in the process development workflow above. The components of the KR2i system are depicted on this slide as well. This would be the full suite of options and accessories that you can purchase with the KR2i. The base system includes the main peristaltic pump drive, a Surface Pro tablet as the HMI with the preloaded KFCOM software. Other add-on components include scales, up to 2 additional pumps, and the new conduit device, which I will talk about in a few slides. The KR2i pump can be controlled manually or automatically with 6 different automated TFF modes. The automated modes of operation are shown here on the right and cover a wide range of common modes of TFF. The modes of operations include concentration, diafiltration, constant feed concentration, and a combination of these. As mentioned before, users can input the desired operating TFF parameters through the KFCOM interface. KFCOM will also record and display process data that include pressure profiles, concentration factors, and filter flux in real time. The control screen is easy to navigate and intuitive to use. It displays parameter pump rates, weights, and pump modes. Both operational and data collection screens are Excel-based so that data can be easily accessed on other computers. For those who perform TFF, you know that it's important to understand the pressure profiles of your process. Knowing the pressures within your system is a good way of tracking the performance of the membrane being used, and also a key parameter for scaling up process in the future. Inline or Luer-connected single-use pressure transducers are key components of the KR2i and allow for real-time process monitoring of feed, permeate, and retentate pressures. A question that comes up from time to time is, what other purpose can pressure measurement serve in a TFF process? With the KR2i TFF system, pressure alarms and stops are built in to ensure safe operations and product breakthrough prevention. For example, a drastic drop in feed pressure may suggest a leak in the system somewhere. Alarms and stops can be implemented so that if this was to occur, the system can warn end users of a problem as well as stop the process immediately. Unique to our KR2i system is the Crossflow Automatic Back Pressure Valve, or ABV. TFF can only occur if transmembrane pressure, or TMP, is present across the membrane in use. The ABV can apply an external back pressure and monitor user-defined set points that have been optimized for your process, ensuring robust and repeatable operations. The ABV does this by continuously communicating with KFCOM and adjusting the pinch valve accordingly as solution viscosity changes through a process. The KR2i can also control TFF operations via feed and permeate weights. Permeate scales measure the total permeate mass and transmits the results to KFCOM for calculations of concentration factors and permeate flow rates. For diafiltration and constant feed concentration operations, KFCOM software will maintain user-defined weight set points on the feed scale. Auxiliary pumps, such as the KR Junior, are used for diafiltration, constant feed, and buffer additions. Additionally, these pumps can be used as permeate pumps to control the rate of permeate flow if necessary. In addition to pressure set point alarms and shutoffs, the KR2i has been designed to include 6 user-defined alarm set points and auto shutoff capabilities based on weight. This is to help ensure that your process is run safely and in a controlled manner. Examples of alarm set point utility include prevention of the feed reservoir weight or volume dropping too low, and notifying end users that the desired permeate volume has been collected. Now, we have just heard about the KR2i and its ability to automate your TFF process based on pressures and weights. We're now very excited to add the conduit to our suite of system components. Conduit is an add-on module ready to use with new and previously installed KR2i systems. The Conduit supports real-time monitoring and endpoint control of solution conductivity, UV, and temperature for TFF operations. With the launch of Conduit, KFCom is now capable of controlling your process via conductivity, UV, along with weight, either independently or in conjunction with one another. Conduit can support 2 independent temperature and conductivity readings, as well as 2 UV readings. Repligen is offering UV photometers at 260 and 280 nanometers. KFCom has also been updated to plot real-time data of conductivity and UV readings during your run. This run data graph shows retentate conductivity here in green and the volume of diafiltration buffer as a function of time. You can see as the conductivity reading is decreasing, the amount of diafiltration buffer increases over the course of this TFF run. The Conduit device enables endpoint control of TFF operations, including conductivity control for UFDF applications, UV control for diafiltration applications, and endpoint concentration control for certain molecules. To de-risk TFF operations, the UV detection capability of Conduit can be used along with UV alarm set points for the detection of product breakthrough in the permeate due to an issue with membrane performance. The Conduit device with UV, conductivity, and temperature measurement capability further enables the KR2i system with added levels of TFF process control, resulting in process development time savings as processes can be optimized with real-time, inline conductivity, and UV measurements. I had mentioned the KMPI system earlier. The KMPI is a scaled-up version of the KR2i and is designed for pilot and GMP scale operations of 10 to 1,000 liters of working volume. The main peristaltic pump drive on the KMPI is capable of flow rates of up to 13 liters per minute. A full suite of accessories designed for scale-up and analogous to the accessories of the KR2i are also available, allowing your processes to be directly scaled up from the KR2i to KMPI system. The software and control logic between the KR2i and the KMPI systems are identical, so moving processes from bench scale to production is easily accomplished. The Conduit has also been designed for full functionality with the KMPI as well, so processes and set points can be easily adopted to the larger scale. Repligen offers single-use filter assemblies that are fully compatible and optimized for use on the KR2i and KMPI TFF systems. These flow paths are fully customizable and are defined through an engineering design process. In other words, they are designed for your particular application. Assemblies include a filter, configurable tubing sets, and integrated sensors. They can be designed with both Spectrum hollow fibers or Tangenix flat sheet cassettes. Repligen offers multiple chemistries of hollow fiber membranes, and they allow for fast processing with high flux rates. Tangenix flat sheet cassettes are available in 2 different chemistries, ProStream or low binding, and the HighStream hydrophilic membranes. Both platforms are also fully scalable. ProConnex flow paths can be gamma irradiated so they are sterile and ready to use upon delivery as a true plug-and-play option for your TFF application. Taken all together, custom ProConnex flow paths allow for fast and simple setup and reduced downtime and enhanced process efficiency. In conclusion, the KR2i and KMPI automated TFF systems by Repligen are ideal systems for your UFDF applications, from process development to larger scale manufacturing. These systems are modular and configurable and can be arranged for your particular application needs. With the addition of the newly launched Conduit, the KR2i and KMPI systems can be further enhanced with conductivity, UV, and temperature control and monitoring. These systems are fully compatible with both Spectrum hollow fiber filters and Tangenix flat sheet cassette platforms. And with ProConnex single-use assemblies, can be optimized to your particular needs in an easy and ready-to-use flow path. If you would like to learn more, I invite you to please visit the link below. With that, I'd like to say thank you for listening and for your time, and I am happy to answer some questions.
Thanks, Phil. So the first question we have is, what are the advantages and disadvantages of hollow fiber versus flat sheet cassettes?
Yeah, so certain applications will tend to do better with either flat sheets or hollow fibers. Major differences include, at least with flat sheets, turbulence promoters. So with these turbulence promoters, the flow path for a flat sheet is slightly different. So what happens is generally you're running at higher transmembrane pressures. So certain molecules will do better with higher TMPs while other molecules do not. Other advantages include drainability between hollow fibers and flat sheets. Generally with hollow fibers, I find that drainability is a little bit easier. But with flat sheets, you tend to have a little bit of a higher flux due to higher operating pressures.
Okay. And how do you determine loading onto the hollow fibers?
The loading is going to be dependent on your process. So it's going to be based off of surface area. So we have a formula essentially that says based off of what volume you're trying to process and what you are processing, we could fit you with a certain capacity for a particular fiber or a module. So it's really based on surface area.
Can the retentate permeate pressures be configured by the software, or do they need to be adjusted by hand?
Sorry, I missed the first part. Could you repeat the first part of that question?
Yeah. Can the retentate or retentate?
Oh, the retentate. Yeah.
Permeate, pressures be configured by the software, or do they need to be adjusted by hand?
Yes. So the Crossflow automatic back pressure valve is integrated into the KFCOM software. So you can set the pressure based off of the program, and nothing needs to be adjusted by hand. So you just input the pressure that you want on either retentate or permeate, even the feed or TMP, and you essentially let the software do the work for you.
And does Repligen have its own sensors?
Pressure sensors or?
This came up during the presentation.
Okay, yes, we offer our own sensors.
Yep, pressure sensors.
Yeah.
Okay, and are your membranes reusable? If so, how do you clean them?
They are reusable. We like to say single use, but usually it's just sodium hydroxide, 0.5 molar or normal sodium hydroxide, and then storing at 0.1 if you're holding on, or storing them for extended periods of time.
Okay. And what concentration can the conduit measure up to accurately?
Yeah, so with the conduit, it depends on the molecule that you're trying to analyze. With proteins, the maximum concentration is probably about 5 mg per mil right now. But for other molecules, we can go up to much higher concentration. So it's really dependent on the molecule that you're analyzing or you're running through your process.
So if someone has less than 2 liters per minute flow rate, which of your systems would you recommend?
Less than 2 liters per minute per flow rate, the KR2i would be fine for that.
Okay. Well, thank you very much, Phil, and thank you to our audience.
You're welcome.
The recorded version of this webcast will be available for on-demand viewing on our website, and as a registered attendee, you'll receive a follow-up email providing you with a direct link. We look forward to having you join us at future Bioprocess International Ask the Expert webcasts. Look for those announcements in your inbox. Thanks again. Have a good day. Bye.